Is the screen is visible?
Yes, sir.
Okay. So in the previous class, we have discussed about the resonance, series resonance, parallel resonance, and all the things we have discussed in the yesterday class. So I think we have started the evaluation method also, where we have to evaluate the harmonic distortion here now. What happened? Just a minute. Why some people are still joining? So in the yesterday class, we have started already about the harmonic distortion evaluations. Okay. So actually, how we are going to evaluation, we have to do the distortion. The distortions, whatever the harmonics are there, they will start to flow towards the utility system, actually where the sources are there on that side. So the harmonic distortions are available in between the end users and the utility side actually. Okay, based on that, we are going to evaluate the harmonics at 3 places. Okay, first one, that is called end users. End users means I was taken one diagram also yesterday. That is the first the generation will start. Okay, from the generation we are going to do the primary transmission. Next we will start the secondary transmission. Next we will go for the distribution system, that is called primary distribution and secondary distribution. We are going to call that one here now. So from this secondary distribution means that is called wherever you will get the pole mounted transformer, from that one you are in your area, you are going to tap the power supply and you are going to take to your houses. So that is called this one, whatever you are going to use the electricity, that is called you are the end users. Okay, you are using a lamp, lighting purpose you are using electricity, you are the end users, that one. So who is giving the supply for electrical supply for you people, that is all utility side, we are going to call that one here. That is the this one, the distribution system is utility side here now. So in between from this distribution system, suppose in your Pandharpur only we will consider that we have substations at outside the city. From that substation, different areas load it is connected over there. Okay, from this substation only different areas, even you can consider in your area only, if the pole mounted transformer is there, from this transformer so many areas, left side, right side, other areas, back side here, like that we are going to tap the load. We are going to tap the load here now. So if the we are going to consider this one as here any bus is there, one load we have given, two or more utility connections are given here now. So whatever this point of connection is there, that connection, the point we are going to call as common coupling point, we are going to call that one here. This is called common coupling point here now. Is there any disturbance? So the harmonic distortion evaluations we are doing at the end users we are going to do. So end users is nothing but we are going to call that one individually we are the end users. So based on that, some standards we are using, that IEEE standards, that is 519 IEEE standards, which was implemented in the year of 1992. According to these standards, they have given some limitations, how the harmonic current limits here now, how much current you have to allow that one, like that they have some limitations here now. So that one I will see here. For individual end users, IEEE standard 519 1992 limits the level of harmonic current injection here now. So this standard, according to this standards, they are going to give the limits value here now, harmonic current injection, how much current it should have to inject at the common coupling point, that is called PCC, we are going to call that one here now. Common coupling point or point of common coupling, both are same only here now. At that particular point, how much current we have to inject, how much we have to limit that much currents here now. So we are going to consider that one here now. This is the quantity, sorry, this is the quantity end users have control over that one here now. So based on this, this is the quantity of end users we have the control over that one here now. So the recommended limits are provided for both individual harmonic components and the total demand distortion here now. See, I told in the yesterday class also that total harmonic distortions for the voltage, actually for the total demand distortion here now, that is called current here now. Current harmonics we are going to use that one here now. So here at the end users we are considering maximum the harmonic current injection only here now. So the recommended limits for the are provided for both individual harmonic component, whatever the individual harmonic component, and the total demand distortion here now. It is going to give the total how much demand distortion we have to fit. That is the, it is going to give the limitations here now. This IEEE standard, it is going to give the limitations here now. It is going to limits that one here now. Whatever the limits provided here now, these limits are expressed in terms of a percentage of end users maximum demand current level here now. So in the form of percentage here now, 30%, 40%, like that, the IEEE standard they are going to give the in terms of percentage of end users maximum demand current level here now, based on the end users how much current is required. In your house only you consider that for the lamp and all the things you are going to use for 5 amperes, 6 amperes we are going to use. Okay. For the fridge, washing machine, iron box, how much current is required? Yes, anyone? Fridges, washing machine, iron box, everyone will do the iron.
Six ampere.
6 ampere is for lighting, actually we are going to use that one. So AC, we will provide the AC point in your houses. I don't know how many of you visit that one now. Previously it was not there, but now every houses who were, they are going to start the construction before doing the kind of wiring system. Yes. Yes, anyone? Someone has started. So they are going to provide the AC point. They are going to provide in your where it is some exhaust fan, coolers, like that. They are going to provide the points. We are going to provide heater. Normally we will connect to the 6 ampere only, but actual the current rating required for that one is 15 ampere. We are going to call that one, or 16 we are going to call it. Standard 16 is there, but everywhere in the switches in the shops and all the things, 6 ampere switch, 15 ampere switch, we are going to consider that one. Why means the load, it is going to suppose the 1 kilowatt 1000 watts iron box we are going to use. You compare with lamp here now. Lamp only 9 watt bulb we are using, but we are connecting 1000 watt iron box over there. So the load is increased over there. According to that, the current required for that one is very high. High current is required for the satisfy the loads over them. Like that, the load increases, like that the current should have to current will be increases here. Now, based on that, these what they are going to consider here now. So the demand of required individual or end users current, maximum current level we have to identify. So based on the percentage, we can limit that one 80%, 90%, 100%, like that we can consider that one here now, rather than as percentage of the fundamental. Instead of fundamental level, we can consider the end users maximum demand current level we have to consider here now. So this is intended to provide a common basis for evaluation over time here now. For the over time, this evaluation, this is the intended to provide the common basis for evaluation of the harmonic distortion here now. This is the end user side. Whatever the distortion we have to evaluate means based on this IEEE standard only we are going to limit that one here now. So we are going to limit the harmonic distortion here. Next one, the utility side we are going to consider here now. Utility side maximum we are going to consider the voltage we are going to consider here now. So the total harmonic distortion we are going to consider at this utility side here now. Since the harmonic voltage distortion on the utility system arises from interaction between distorted load current and the utility system impedance here now. See here, whatever the harmonic distortion, harmonic voltage distortion on the utility systems are there, this will arises between of, that is the interaction between the distorted load here now, load currents, whatever the load currents are distorted here now because of some different inductive capacitive loads we are going to add here, the distorted current we are going to consider that one, as well as we are going to consider if the inductance capacitance we are going to add or change that one, remove that one. So the Z, that is called impedance, will also it is depends here now. So based on that, so we are going to do the interaction between the distorted load currents and the utility system impedance we are going to consider here now. So the utility is mainly responsible for limiting the voltage distortion at PCC, that is common coupling point we are going to consider here now. So the utility system, it is responsible to limit the voltage distortion actually. How much voltage it should have to maintain here now. Excess voltage it should have to bypass that one, and so limiting the voltage level it is going to limit here. So that is the main responsibility of the utility system. Okay, so the voltage limits are given for maximum individual harmonic component here. Previously at the end users we have considered TDD, total harmonic distortion, sorry, total demand distortion. Here we are considering total harmonic distortion we are considering because it is a voltage distortion we are maintaining here now. So these limits are given for maximum individual harmonic components for the total harmonic distortion here now. So individually how much limits we have given here now, individual harmonic components, and for the total harmonic components we are going to consider, that is distortion we are going to consider here now. Whatever these values are expressed as the, again here also we are going to consider as percentage of fundamental voltage here now. See here percentage of fundamental voltage we are going to consider here now. See here, from the generation to end user you are going to give that one, the transmission distribution you are going to do that one here now. So anywhere you will use that one power, no, it is generation is 11 kV, transmission we are going to do that is 220 kV. Next the primary transmission system, again 120 kV we are going to shift that one. Next from the primary distribution system 120 to 11 kV we are going to shift that one. Next to 11 kV to 440 volt we are going to consider here now. See, this all the things you consider that one. Which one we are using? Based on the voltage only we are converting this all the supplies here now. 11 kV to 220, 220 to 120, 110, 110 to 11, 11 to 400 here now. So these all are the fundamental for the single phase or industrial users, that is 3 phase 440 volt required. For the small industries and other things. The bigger industries, they will take directly L1 kV load, they are going to take that one. So that is called, that is fundamental voltage. This L1 kV is fundamental voltage, 440 is the fundamental voltage here now. That industry persons, they are taking the L1 kV load, but inside that load only, load area, whatever there in the building only, there they will make their own substation, and they are going to maintain that one, converting that L1 kV to 440 as per their requirement. They are going to do that one. So many industries are there. Okay, so like that. So these, whatever these harmonic distortion values are there, these values are expressed as the percentage of the fundamental voltage here now. How much percentage of fundamental voltage we are going to use here now. So for system, suppose we'll consider that is 69 kV. See here, 69 kV, below 69 kV, the total harmonic distortion should be less than 5% here. The harmonic distortion should be less than 5%. Sometimes the utility system impedance at harmonic frequencies is determined by the resonance of the power factor correction capacitor banks here now. So what we are going to do, we have to maintain the total harmonic distortion at 69 kV, that is 5% we have to maintain. But what will happen, sometimes the system, the utility system impedance at harmonic frequency, it is going to vary over there. Okay, so system impedance at harmonic frequencies is determined here now by using, by the resonance here now. When the resonance will occur, so we have discussed that one, if it is harmonic or non-harmonic component. But by using the power factor correction capacitor also, sometimes it is not creating the harmonics, but it will create a problem, that one here. So it will create a rise of voltage or current here now. So the resonance of the correction of power, what is that one, power factor correction capacitor banks here now. So because of this, what is going to happen, this results in very high impedance here now. The impedance of the system will be very high, and high harmonic voltages are produced over there. So under the resonance condition, because of the resonance, the utility system impedance will change. So at the harmonic frequency, it is going to change. So this will result, that is very high impedance and high harmonic voltage, it is going to implement that one here. So we have to limit that one here, the, that is plus 5% acceptable here, that one. Other things are, that is harmonic distortion, that is the voltage distortion is not acceptable. Therefore, compliance with IEEE standard, again we are going to compare with IEEE standard 519/1922, often means that the utility must ensure that for this problem to increase very high impedance and high harmonic voltages, the utility system must ensure that the system resonances do not coincidence with the harmonic frequency here now. Under resonance condition, the resonant frequency is there, it should not coincidence with the harmonic frequency. If it is coincident with the harmonic frequency, then it will cause us for the very high impedance. So high impedance will cause and high harmonic voltage will be increases here now. We have to ensure that so many components are there, we can use, by using those components, we have to ensure that the resonant frequency and harmonic frequency should not coincidence each other. So then we can control that one here now, according to this IEEE standard, that is 519, they have told here now, with harmonic frequencies present in the load currents here now. So this is the, at utility side we are going to call that one. This one is at utility side here now. So for the utility side also, we are going to concentrate at common coupling point only. For the end user side also, we are going to concentrate on common coupling point only here now. So this is the point of common coupling or common coupling point we are going to consider here now. Look at this diagram here. Look at this diagram. See here, customer under study here now. We are the end users we are using here now. And here other utility customers are there, and some utility system is there here now. So here the utility is there, here the utility is there, here customers are there. So at this point, that is called common coupling point, we are going to tell this one. This is the common coupling point here now. So any distortions will occur, they will comes at this point only, we are going to evaluate here now. See here, we have connected here the other utility system, that is common point we are going to consider. At the end user side only, we are using different loads here. Now here customers are different, other utility customers we are going to use. So where the utility system, other utility users and end users connected here. Now that point we are going to call as common coupling point. We are going to tell that one here. So evaluation of harmonic distortions are usually performed at a point between the end user or customer. Whatever the end users are customers, we are the customers here now. And the utility system, whether another customer can be served over there. So utility system, I will tell that one. I think to whom you are going to pay the electricity bill. आप electricity bill किसको pay करते? What is the company name? बोर्ड क्या है वो, कुछ तो है ना, MS? Anyone? Everyone will pay the electricity bill every month.
MSCB.
MSCB, okay. So you are going to pay the electricity bill. How much you are going to utilize? You are going to pay the bill for them. Okay, for that, to them. So on that condition, you are the customer of that MSCB. Yes or no?
Yes.
You are the customer of MSCB. You are nothing but end user. The utility system is, they are the utility systems over there. But MSCB, how they are going to get the electricity supply from the generation? They are going to get that one. Is the MSCB part, generation is part of MSCB? No. So that the utility system where another customer can be served over there. So by using the different utility systems are there. So like that, some reason wise distributions are alag, like that different customers we can connect that one here. Now the point where the utility system and end users and another customer where it is connected here. Now that point is known as the point of coupling point, coupling or common coupling point. That is called PCC. We are going to call that one. We are going to call that one here. The PCC can be located at either the primary side or secondary side of the service transformer here. Now we can connect at the primary side, or see here the pole mounted transformer in your area, that is called secondary distribution. We are going to call that one. Yes. So we can connect at the primary side of that transformer or at secondary side of the transformer here now. So the PCC can be located at either the primary side or the secondary side of the service transformer. That is depending on whether or not multiple customers are supplied from the transformer here now. If the multiple customers are not supplied, whether they are telling that one, whether or not here now, they may connected or not connected here now. In other words, if multiple customers are served from the primary of the transformer, then we are going to, the PCC is then located at the primary side. We are going to call that one here now. If the multiple customers are connected at secondary side of the transformer, that is called the common coupling point. If they are connected at primary side, then that is called, that is the common coupling point we are going to call. It may be secondary side or primary side. We have to consider where multiple users are connected. That one we are going to consider as common coupling point. We are going to consider that one here. On the other hand, if multiple customers are served from the secondary of the transformer, so the PCC is located at the secondary here now. See here the primary side here now, this is the distribution transformer is there. So primary side, multiple users are connected here now. Here the other customers are connected here now. From this point here now, here the utility system is there. So the primary side we are going to consider as common coupling point. So here at this side, the secondary side, multiple users are connected here now. So this point we are going to consider as the common coupling point. So just a minute. Some internet connection problem is there. I'm out of station actually for that reason. Okay, is the screen is visible? Screen is visible.
Yes, sir.
Okay. So at this side here, the primary is connected to the multi-users here now. So at the primary side, we are considering gas, that is common coupling point we have considered. At this system here, that is here the secondary side, it is connected to the multi-users are connected here now. So the point where it is connected, that is multi-users, that one we are going to consider as common coupling point here now. That one only they have mentioned here now. If multiple customers are served from the primary of the transformer, the PCC is then located at the primary here now. In the other hand, on the other hand, if multiple customers are served from the secondary of the transformer, the PCC is located at the secondary here now. This is very simple. So this is the harmonic distortion evaluation methods where we are going to limit the distortions here now. So the next one, that is called so the devices for controlling the harmonic distortion here. Harmonic distortions are coming. We have discussed about that one. Okay. If any faults over there, suddenly loads, adding, removing, and all the things, short circuits, open circuit, under the resonance. So the distortion will come. Okay. Those harmonic distortion we have to control. So the devices to control the harmonic distortions are there. What are those devices? Different devices are there here now. So to control the harmonic distortions, actually, there are three different solutions can be adopted here now. There are three different solutions are there here now adopted in the reduction of harmonic distortion. So to reduce the harmonic distortion or to control the harmonic distortion, we have made the system into different solutions here. Okay, out of so many solutions are there. Out of those solutions, only three we are going to consider here now. The first one is reduction of harmonic emission from non-linear load here. We are going to use the non-linear load. Okay, we are going to use the non-linear load, but we can reduce the harmonic emission here there from that component. How it is possible? It is possible by doing the modifying their structure of that device. By modifications of structure, we can reduce the harmonic emissions of the non-linear loads. We can do that one. Okay, just a minute. Okay, sorry for the disturbance. So to control the harmonic distortions, we have modified three solutions we have find out here. The mainly there are three solutions are there to control the harmonic distortions over there. So first one, we have to try to reduce the harmonic emission. We have to try to reduce first. Okay, we have to reduce the harmonic emission. How it is possible? So the nonlinear devices or loads we are using in the system, those we have to modify their structure. By changing their structure, by modifying, by using different materials, we can reduce the harmonic distortion. We can reduce that one. Okay, that is first one here now. Second one, we can use the high harmonic filters. We can use, that is, we can active passive filters are there, active filters are there, can use that one. And the third one is isolate here now, isolation and harmonic reduction transformers we can use here. The transformers are available in the market. The isolation transformer is also there, harmonic reduction transformers are also there in the market. So we can reduce the harmonics or control the harmonic distortions by using, by referring these three methods. We can reduce that one here now. Okay, so here the devices used to control the harmonic distortions are, so some devices are there. We have told that one, this is the main, the modifications of their structure, the filters we can use, isolation or harmonic transformers we can use here now. How we can do the modifications of structures and all the things over there. So other than this, some different devices are there with considering this, not other than this. So the devices that is called reinforced distribution system we are going to use. The distribution system we have reinforced that one here now, that is also it is possible to reduce the harmonic distortion. That is filters we have referred here now, that is called active filters, passive filters. So the isolation transformers we can consider, high harmonic mitigation or reduction transformers we are going to use here now. So multipulse converter we can use, instead of 3 pulse, 2 pulse, that is 1 pulse, we can use the multipulse converter, that is called 12 pulse converters. They will reduce less harmonics over there, like that. So you have to increase the pulses we have to increase over there. So these are the devices we are going to use for the controlling the harmonic distortions here now. So next the part is, that is called the filters we are going to use here now. So this part we'll discuss in the next. Okay, I have one meeting now at 10:45. Just a minute. I'll take the attendance. Next we'll stop that. Directly I have admitted all peoples today. Be alert. I am telling you peoples, be alert. I am going to take the attendance. I will call your roll number. You have to give the answer. Otherwise it will be considered as absent. Remember that. Roll number 1.
Yes, sir.
2. Roll number 2. 3. 4. 5. 6.
Yes, sir.
7. 8. 9.
Yes, sir.
10. 11.
Present.
12. 13.
Yes, sir.
14. 15.
Present, sir.
16. 16, 17, 17, 18.
Present, sir.
Who is that? 18 is present. Okay. 19, 19, 20,
Yes, sir.
21,
Yes, sir.
22, 23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30, 30, 30, 31,
Present, sir.
32,
प्रेजेंट सर
33. क्या स्पेशल है? डोंगरे और 31, 32 दोनों प्रेजेंट है आज. बोराटे दोनों प्रेजेंट है. हाँ, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42,
प्रेजेंट सर
43,
Present, sir.
44,
प्रेजेंट सर
45, 46, 47,
प्रेजेंट सर
48, 49, 50, 51, 52, 53,
प्रेजेंट सर 51 प्रेजेंट सर
51 प्रेजेंट है. 52, 54,
Present, sir.
55, 56,
प्रेजेंट सर
56 प्रेजेंट है क्या? 57, 58,
58 प्रेजेंट सर
59, 60,
Present, sir.
61, 62, 64, 65,
प्रेजेंट सर
66.
Roll number 5, sir. Present.
39 सर
Roll number 5, 39.
हाँ
39 present. 63. Are you there? Tambule Arbaj. दीपक हुम्बे ज्वाइन हो रहे, एग्जिट हो रहे, ज्वाइन हो रहे, एग्जिट हो रहे. Okay, roll number 3, 2, 3, 4, 7, 8, 10, 12, 16, 17, 19, 22, 24, 30, 33, 34, 35, 36, 38, 39, 41, 45, 46, 48, 49, 50, 52, 55, 57, 59, 61, 62, 63, 64, 66. These are the absent numbers. If anybody is there, can let me know.
Roll number 12.
Roll number 12 present.
Yes, sir.
Okay. Who is this?
39 also सर
Number 14 present. 14. कौन बोल रहे? 30?
9
39. कब ज्वाइन हो रहे हैं?
सर रेंज प्रॉब्लम था जरा
ठीक है. So these devices actually they have mentioned here now, mainly categorizing into three categories here now, three different solutions. From these two solutions, in this syllabus, they have mentioned only about the harmonic filters here now. The harmonic filters they have mentioned. So this harmonic filters we'll discuss in the next class. We'll discuss about this harmonic filters here now. Okay, we'll stop here only. Roll number 12 also present. 12, okay. 39 बोले ना आप कोई तो okay, so be ready for the second chapter test. Almost this is the end of the chapter only here now. So already in this one, I have explained the active filters. Only this you can study. I will explain, but you can study this passive filter only here now. Mainly here you have to concentrate on advantages, disadvantages. All the explanation will come from this advantages and disadvantages only here now. So in the yesterday class only I have taken complete explanation of this active filters, already have done that one. So anytime I can conduct the chapter test. This part is not done, but by reading this, at least you are in final year, you can do this one. So in the next, maybe the chapter test I may conduct. Okay, so be ready for that one. Already assignment booklet is uploaded in the drive. Teaching diary assignment booklet hai na? Not assignment booklet, MCQ booklet. MCQ questions are available in the, where it is, teaching diary. Yes or no? Anyone have you browsed? Anyone have you browsed that? Can check the teaching diary. In that one, assignment, MCQ booklet is I have uploaded and I have given provided the link on that one. So you can practice those questions only. All the chapter text questions will be from that booklet only here. From that booklet only, I'm going to adding the questions. You can search that one or whatever you can do that, anything. Okay, so we'll stop here only. अटेंडेंस देखो तो 35 स्टूडेंट्स है, दिया है बहुत लोग, मेरे को समझ में नहीं आ रही कितना लोग, इतना लोग कैसे दे रहे हैं. ठीक है, so we'll end here only. We'll continue in the next class. You can leave the meeting. Yes. 29.